Sam is an entrepreneur and is developing a unique wall system east of Edmonton, southeast of Edmonton. And he's going to let us know all about his process in developing a unique product today. I'm really excited about this. So let's let Sam take it away.
Well, thank you for the introduction, Kim. My name is Sam Kondratski. Today, I was going to talk about how entrepreneurial thinking can accelerate the implementation of passive building principles. So a bit about me, I'm just the owner of a startup getting going with some prefab just south of Edmonton. And I studied business at the University of Calgary for a couple of years, just majoring in entrepreneurship and innovation. And if you're going to remember one thing about me, it's that I'm working to maximize the positive impacts of the built environment. And so last winter, I started researching a straw insulated prefab building system. And so really focused on making zero carbon building envelopes accessible to as many people as we can. And so this has involved, experimenting with chopped straw insulated walls, floors, and roofs, often in a panelized delivery format, but also looking at some modular prefab as well. Really what we're going to be focusing on today is some entrepreneurial thinking principles. So, taking an innovative approach to things, exploring the business case that's associated with actually implementing those solutions, and then relevance to passive building practices, and kind of intermingle throughout, talk a little bit about Savic's journey, some of the really interesting wins we've had so far, along with some of the challenges that I'm expecting. Before I think you really focus on the individual improvement or the technology itself, I think it's important that you get at the core motivation of why you're putting your limited energy in a certain place. And I think this is going to be best accomplished with a question. My big question is why so many buildings struggle to meet the needs of people on the planet. And I expect audience members are going to have a similar interest, but everybody's unique. And you have to start thinking, kind of the why behind all of this. And I mean, with passive building practices, there's lots of things that I think you can solve, by building, better envelopes that are more resilient. But I think it's also pretty easy to kind of get lost in just the array of these really big problems. I mean, depending on who you ask, like half of global greenhouse gas emissions are coming from constructing new buildings and then operating existing buildings. There's more specific things, of course, but I think it's really important that we can focus on one thing. And part of picking a good problem that you're going to try to solve is understanding the potential net impact a solution could have. So maybe you're going to be impacting a lot of people in a smaller way, or maybe you're going to be building a couple passive homes every year where now a family is significantly reducing their energy bill. So just starting to think about kind of what you want to accomplish, and then also what you're physically able to get started with. For this, we're looking at what we call available means. So what do you have like right now, and what do you think you can get? This could include past experiences you might have, or transferable skills. It could be the people or maybe you have some physical or financial resources. But ultimately, we're going to be dealing with scarcity. Like, we don't have unlimited resources to address these problems. And I think that's a good thing, honestly. A bit of an anecdote. I mean, when I was first kind of talking about and researching Savic, I kept getting told by lots of people that I would need to raise, $5 to $10 million to get set up, with a production facility. And I don't have that. I don't have millions of dollars. But what I did have is, a corner of a farmer's field. And so, with the help of my 80-year-old grandfather, we were able to level it out. We set up a small shop. We're building another shop there now, but that cost $10,000. So just looking at kind of what do you have at your disposal and what can you leverage? And there's some lessons there. Even in the future, I might have wonderful, big facilities, but I think, being able to maintain and utilize the resources effectively is going to be critical in actually doing this in a sustainable way. One thing I really like, kind kind of just approaching creating these solutions for the problems once we've picked what we're going to be focusing on is treating it as a very cyclical process. So once you have an idea, build it as soon as you can. This could be physical, like in my case, working with hardware, like physically creating samples of different installations and building different wall assemblies and trying things out. But you could be working on an app and just sketch it out. How would that work? Get your mind wrapped around it. But then get others to help you kind of measure its pros and cons as well too. Get it out there and get feedback from the real world, and don't just work, in your own little chamber. So once you get that feedback from what you've been able to measure for your new product, you can learn, and then that's probably going to create new ideas. And sometimes you're going to have to pivot. Like I've had lots of very stupid ideas that I've had to move away from, but sometimes it's a good idea and you can persevere with it and keep going and trying to look at how it can be made better, but in a realistic sense and not just playing around by yourself for many hours. When you're looking at researching and developing your solution, I think you should be aware of what people are already doing to solve a similar problem. And I think this is going to be really important in describing why what you're doing is different, why it's a stronger solution, and why you are in a better position to develop it than others. When we're looking at kind of the value proposition of your products, you're thinking about maybe the product or service benefits. This could be cost or quality, it can really depend. Looking at customer experience, maybe there's some really interesting features that can be associated with the environment, or looking at the different social issues. What it comes back to is understanding, like, why are you going to be working on this? And typically you're going to refer to this as your unfair advantage. It could be your intellectual property. Maybe you can patent your new technology, but often it's going to be just looking at your positioning and your timing, and then you can incorporate those aspects within your available means to actually go and start to develop your solution a bit further. I really want to point out, like, a solution is only going to be useful if it's used, and understand like who could be using it, because a lot of new products, they get developed and it can be very expensive to develop new products, and they don't get past that innovator customer base. I think right now with higher performance building practices, whether it's passive house or net zero, I think it's starting to get into that early adopter territory where I think the novelty is worn off a bit, but now we're really looking at the motivations for what can be accomplished, and just understanding, despite big goals like net zero 2050 or really stringent building codes, like understanding who's going to be able to build and afford these spaces and what those customers' values are going to be, and how you could maybe cater your product or your service to be in line with those values. And once you know who you're targeting, it's time to sell your solution to them. This is going to probably start, with bringing a bit more awareness to what you're trying to do. Can progress, to actually, going and looking at, some of the detailed pros and cons of your solution, and helping people, seriously consider what you're working on, turn that interest into action. And if you're able to, to sell your new product, or maybe your existing product that's been improved, and you've able to have, good customer service and did what you said you could do, those customers are probably going to be your best salespeople, even if they're not going to be buying from you again. Just being able to create a real tangible backing behind what you're doing, and not just a bunch of hype surrounding a new technology. And then the other side of this is thinking about how you can effectively distribute it to people, whether you're going to be teaming up with another company, or if you're going to strike out on your own, be selling business to business or direct to consumer. This of course really depends on what you're selling and when you're selling it, but just to be thinking about how could this get out into the world. And then you have to go one step further, is thinking about how is this going to be sustainable, thinking about the different ways that your business can make money, and you can reinvest your hopeful profits into making it even better for the future. There's lots of different ways businesses make money today. A lot of that has to do with the pricing models that you're putting into place, but worth considering that you might not have as much flexibility, with your pricing as you think, just because the market is going to be dictating that anyways. In my case, with it being kind of it's a relatively unique thing, we kind of be careful about how we're pricing it, because there's not a ton of great benchmarks, but just thinking about doing this not just as a one-off, but how you could continue in the long term. I really like to be thinking about developing, new products all the time and like production, and that's where I'm happy. But do have to give some focus to the money side of the equation and how you're going to be able to afford all this product development and get through the valley of death where you're not making any money but you're spending money, quickly turning that around into a successful product. That's not easy, and that's why most startups are going to fail. But I think if you have a strong understanding of what your burn rate is, how much cash you have in the bank, and have a bit in there for contingency, you're going to be better off than if you were just striking out blindly into the wilderness. And even if you're not working with a government grant or an external investor, I think it's still important to set goals and targets to understand if you're on track with your original intent. Just going back to that startup or that lean startup methodology, like keep trying things out, keep measuring the impacts of what you're doing and learn from the wins and the failures. Because if you can't capture like that validation of going out and doing things, if you can't learn from it, it's really hard to continuously improve or even survive to do the next project. I guess to kind of summarize this, you don't need to be manufacturing building products to apply entrepreneurial thinking principles. There's dozens of problems in addition to the ones that I flashed on that first slide that can be addressed with furthering passive building practices. So whether you're looking to start a new venture or working within an existing company, just know that innovation is going to be critical in building a better future. Just to review what we talked about quickly, we looked at how to pick a good problem, ways we can experiment with those solutions, start to explore the business case associated with implementing it, and then going to that validation piece and how do we capture what we've learned and hopefully we can replicate it in the future. I'm just going to quickly talk about how I've been applying these entrepreneurial thinking principles at my startup, Savic. I spent a lot of time picking what problem I wanted to focus on. And so before getting started, in the construction industry, I was looking at calculating greenhouse gas emissions for small businesses and developing a small scale carbon offset project. So I knew that what I wanted to do was going to be actively storing carbon and approaching a solution from that perspective. But a lot of what I ended up learning was just by going out and talking to people, getting some insights from people who are actually potentially going to buy this in the future. And what are their pain points? What are they concerned about? Because what I'm concerned about, like I'm very passionate about it, of course, but that doesn't always translate to the people who would actually be using this new solution. And another point, just to add to this, I'm really excited, and a lot of great things have already come, just for the ability for average people, just with access to the internet, and what they can do to truly expand their skills and their knowledge on a wide variety of projects. Like I knew how to swing a hammer before I started working on Savic, but I do not come from a construction background. I did not know how to model things in Revit, but with the internet, it's more than possible to learn these new skills and then try them out in the real world and see how that goes. And so the problem that I really ended up focusing on here is how do we get the straw from the farmer's field into a high performance building? And it turns out it's a very tricky problem to solve, but that's why I've started Savic, looking at the millions of tons of straw that get produced in Western Canada every year, and how can we get that into a building that's climate resilient, that's low carbon, and that's comfortable and safe. So it's been really interesting to be looking at all of the pieces that go along with it. It turns out when you try to solve one problem, you end up solving like 20 of them. But it's nice to be able to just have this as kind of our guiding principle as we go through a bunch of different things. Looking at just experimenting with the solutions here, the first batches of straw insulation that I was working on, it was not in a laboratory. It was with some borax from my mom's laundry room and like a kitchen scale, seeing what worked on a benchtop prototyping, just very small scale, rudimentary tests, and later finding out that did reconcile with the actual scientists who are working on this stuff. But just being able to wrap your head around what you'd want to be working on in the future. This is also really helped by being able to model things out and kind of seeing how things are going to interact just in the virtual world, and then you can work on translating that into the real world. Eventually you can create some pretty interesting prototypes and demonstration projects. Then, I was kind of left to explore the business case. And as a business student, I really enjoy just looking at the market mechanisms that can enable the adoption of new technologies. So I've participated in a few pitch competitions and have won some prizes. And from that, lots of doors have been opened for access to really good mentors and advisors. But just being able to think about how can this idea, even though it may be deeply rooted in environmentalism and looking at some of the social issues, how can this make money and how can this sustain itself? This is really helped out by just the Western Canadian startup ecosystem. There's dozens and dozens of talented people from all walks of life who are starting out and trying things. And sometimes it's throwing a bunch of spaghetti on the wall, but you do see what sticks. Hopefully the market is going to reward that. And then really just learning from what you're doing is just so critical. It's getting the real information. This cuts out the speculation associated with the future work that you're going to have to do. And so whether that's working with a great organization like Sage Green Building Laboratory to get some early thermal testing done, or doing a full-scale demonstration project to really see what does it look like when you have a 3,500-pound straw insulated roof panel flying through the sky? Is this going to be reasonable? Can you actually build a business off of doing that? Capture what you've learned, and then hopefully it can be replicated and improved in the future. Some of the biggest wins, I'm really excited about getting set up with a new production space and a growing team in Leduc County. We got lots of interesting designs that have been worked on over the last few months, and really excited about the interest that we've received so far. And now with the demonstration project complete, it's going to be even more interesting to deliver these straw insulated building envelopes to a wide variety of future projects. Starting SAVIC, I did not think that it was going to be as challenging as it was. I'm really happy with where things have been. But for every one problem you solve, you probably discover 3 more. Basically, just continue to learn by doing and trying the straw building system out on a wide variety of projects. Planning even just some modular accessory dwelling units, looking at maybe some panelized single family agricultural projects. It's going to be a very busy year. And depending on SAVIC's resources, I'm really looking forward to some more product testing and getting some more certifications so that we can deliver the straw system on some really demanding projects, thinking about industrial buildings or commercial buildings, and just seeing where this product will really fit into the market and where it's going to be able to generate the most amount of value for people, and have the biggest impact on the things that I'm passionate about. How can we really take climate action? How can we really promote a positive built environment? Thank you for listening to the presentation there. I think we've got to probably take a few questions and talk with Kim here.
Thank you, Sam. That was awesome. Anybody has any questions, just go ahead and ask.
This is Jonathan here. Thanks for the presentation. It was great. I was really looking forward to hearing about your product. I'm just wondering what kind of code compliance issues you're running into now and what's still outstanding.
Some of the biggest ones just expect to run into, because right now it's still pretty early, is going to be trying to reduce just the engineering burden as much as possible, because would just be an alternative solution, to the building code, because it's not a prescriptive, insulation material right now. It's just how can we, have those standard details that are stamped by an engineer? How can they be used a number of projects, and just trying to keep, instead of $15,000 per project for engineering, how can we maybe get that down a little bit so that it's something that would still be accessible to a more affordable development.
If you're delivering these buildings as pre-manufactured and they're modular homes, they will have to be certified, CSA certified, correct?
Definitely planning on getting this Leduc County shop certified to the CSA A277. That way, we can have plumbing and electrical done in the shop just with local contractors. And I think that's really going to help with the remote projects. Instead of having to coordinate trades out there, we can deliver a pretty high level of finish on the units, but then also just thinking recently about how we can maybe integrate some of the MEP into the panels as well, where it might make sense. For insulating a floor assembly, for example, maybe we can do the plumbing in the shop and then be able to deliver just a unit where there doesn't need to be an insulation contractor on that project anymore.
MEP means mechanical, electrical, and plumbing, by the way.
Yeah.
If anybody wasn't sure. And the issue with codes officers of just plumping down any kind of building somewhere is that no one, if it's not certified, no one has seen those things installed, and they're hidden behind walls. They're buried. So it's that part of the building that's could be called into question. So that's what one of the bigger problems, I think.
Hi. You said that you have a full-scale demonstration building. Where is it and what is it?
Just in Leduc County here, we built a 400 square foot shed. And so we tried out a few different assemblies, looking at kind of a Larson truss system and then more of an integrated truss system. And yeah, we're playing around with a few different things to figure out what would be the most, the easiest to build in the shop, but then also what's easiest to interact with on site and how the other trades would be affected by what we're doing there.
I'm curious, you're talking about straw. I'd be interested in hearing a little bit about, is the straw purpose grown for your application, or is this straw that exists in the world anyway? And then I wanted to sort of drift that over to my world here, where we have lots of wood. We deal with salvaged wood from the traditional building industry, and we send it out to the agricultural community to be used out there. I'm curious if anybody has experimented with producing a wood product that would be compatible with the straw product, and you could use either one depending on which is available price-wise. And if you go back 100, 200 years, we insulated our ice houses with sawdust, right? Mm-hmm. This is a known product with known insulating property, and I'm looking out my window at probably 2,000 tons a year of wood that might be able to be used for that purpose if an entrepreneur sort of went through the process that you've gone through with straw. Why, as an alternative, lots of people say, oh, it's biomass, let's burn it up and heat our buildings with it instead of fossil fuels. But that's still, in the circular economy, that's still a one-way street. It's a material going into entropy and not necessarily a value added to the resource that we're capturing here at our facility. What
I really was surprised by just researching this was just the amount of byproduct cellulose we have from cereal production that just rots in the field every year, and that has a fertilizer value. You definitely want to accommodate for that in your life cycle assessments and everything, but it's in the field, a bale of straw is maybe worth $15, but installed into a panel, it start to be worth $500 or $600. So not only were we looking at this from like a domestic perspective, I think we could be exporting this as well, like the regions that have lots of straw, like in the prairies. Maybe we can send it out to places where they're not as blessed with this resource. But it does bring an interesting question, though, just looking at the other natural materials that we have at our disposal, whether it's a wood product or whether you're looking at some of the wood-based insulations that are being made, and just understanding like what are the end goals of the project, like what kind of performance do we want to get out of it, and then is this the most cost-effective way to go about it? Because that's really what it comes down to for a larger scale implementation.
Thank you.
Bonnie, you had another question?
Sam, what are your next steps? Where are you going now?
Right now, it's starting to deliver on some of the pre-sales that we have for both some accessory dwelling units, but then also some panelized packages for, again, like kind of a variety of projects. Lots of interest, even just in insulated shops, in agricultural settings, but then planning a couple houses as well, and just being able to piece together, all the considerations that come with that. I mean, whether that's looking at code compliance or just the fact, like, yeah, we've got a big stack of bales next to our shop right now, but how do you get that into a panel? And there's all kinds of fun things that I'm really looking forward to be working on in the next few months.
Thanks for your presentation. It's a great looking product. I do build a lot of outbuildings that need to be heated, so insulation is priority, and we're always looking at innovative things and ways of zero emissions and things like that. So unconventional building styles and that. With the straw, what have you looked at for fire retardant for the straw?
I've experimented, with adding, similar treatments that you would do for a paper-based cellulose insulation, and that proved, pretty effective. It wasn't, formal testing or anything. It's just, in the backyard kind of deal. But right now we're working mainly with an untreated, just chopped straw, and so it's densely, packed into an assembly. And so that's still has very good fire performance. And I'm be hoping to actually get some real numbers behind that though, and actually have a UL listed fire rating for our standard assemblies, so that we know we could use this on a commercial building or in a multifamily, and be able to achieve more demanding applications.
Right.
But yeah, I'm not sure if that answers your question well, but
Well, yeah, it's one question, and the other one was with the module building style that you're using in that. How do you see your cost compared to conventional building, just stick building with sheeting and conventional insulation?
right now, I think for the panelized delivery format, you're probably looking at around $20 to $25 per square foot of panel, and that's around the same for both the wall, external wall, and the roof panels right now. And so for a wall that's arriving on site, at around R36, and that's effective. And then for a roof, that's around R70. So that costs quite a bit less than other building systems like ICF, and just really need to see if that's going to be a sustainable price point for us, or if it's generating enough value for it to be attractive on different projects.
All right, thanks a lot.
Oscar has some questions.
Yeah, okay, Sam, one question is about sometimes the logistics here. Sizes of the product and things like that. Have you developed anything on that sense? And the second thing is, you mentioned that you have some projects. Have they been kind of through the process of being approved by the municipalities or whatever, or it's just because are the buildings that you don't need to have that type of permit?
For the distribution side to this, with the panelized delivery, you're looking at standard size shipping, so it's pretty easy to get, into the city, or, avoid any oversized permit. And our supply chain, for straw, it's like, I think it's a 1 kilometer radius, like we're able to just use our neighbor's straw to get it into a panel. But for kind of the volumetric, modular units, they're a little bit bigger. You still don't need a permit for them in most municipalities, just to try to keep the transportation costs down. But just looking at, kind of the project considerations, whether or not you're able to get a crane in there, or looking at some of those logistics that would come, with just kind of the early consultation for projects. But from a permitting perspective, so far we haven't had any permitted projects. Right now, just getting permits for an affordable development in Edmonton. And we'll see how that goes, just with the engineering that has to be done. And then also just how long it's going to take, because that's a big part of it as well, if we're trying anything new. I know lots of like straw bale homes, for example, they're getting permitted more routinely. So be interested to kind of piggyback off of that momentum. But we'll see, with this being a slightly different product, like the straw isn't as dense as a straw bale system, just to increase the insulation factor. We'll see if there's any difference there.
Sorry, there's a different, because that's the other thing, orientation of the straw inside the wall. Is that an issue there for you or not? Because if it goes perpendicular or parallel, it's usually different R values.
With straw bale, it's critical how you're orienting your bales. Like, it'll change your R value from like R1 per inch to R2.2 or whatever it is. Like, it can be a huge difference. But with this, it's very similar to a paper-based cellulose insulation. So we're actually reducing the particle size down quite a bit.
Can you still tell the municipality that what you're doing is technically cellulose, or they will balk as you?
I've looked at that, talked to the folks just at CCMC, so the Canadian Construction Materials Center, about if it will be able to, do all the testing, for like the chopped straw product with the existing standard, for cellulose insulation. and we don't figure that's the case, we'll probably have to develop our own testing protocol for that, which is not a cheap thing to do. Like I wouldn't be able to do that this year, but if we have enough resources, then we could invest in actually getting this material listed, so that way it doesn't have to require any special. It would just guarantee the special approval for a variance to the building code.
Speaking of cellulose or blown insulation, I understand that you're doing a modular approach to this, but is there any reason why it couldn't become just a site installed material?
That's a really good question. And I think in order to answer it, I have to kind of come back to just the greater motivation of why I really was attracted to straw to begin with. And while it's like a great material for many reasons, it really comes down to costs. I mean, like this blow-in straw product, like it costs 20% of what a blow-in cellulose product is going to cost. But that's when we're able to essentially manufacture it in the same facility that we're installing it. When you start looking at compressing it and baling it and shipping it up to site, I'm not sure if you're going to see the same cost benefits to currently working with the material. But there may be the case where there's certain applications where it is the most cost-effective way, and certainly would be open to it. It's just understanding what the goals are for the project and what you want to get out of that product.
Is there a way to make it a mobile unit? I guess for me, I'm just imagining that in Alberta, we have so much straw. Is there any reason you couldn't just take your unit out to site and with some bales and chop it up and do whatever you need to do and stuff it in a wall?
Yeah, there could be a case there. I think for, kind of far-flung like rural projects, if you're going to go up, I'd be shipping U panels, from, 6 or 7 hours away. That the cost might balance out there to just be able to chop the straw on site. But I think you would have to worry, about the neighbor's rose garden for sure. It's an agricultural process. Like it's very, very messy right now. So being able to, look at putting some controls on that, I could definitely see it, something like that developing in the future.
Do you host tours or anything else like that? Do we just contact you directly to see if we can come see what you're doing? What would be the best way to, or would that be an option?
Absolutely. Yeah, no, I would be anyone who's interested in, and taking a look just at the demonstration project, or even just, come by the shop where we're building panels. I'd be happy to show you around. I think my email is in the slide deck, but I can even just put it into the chat here if anybody wants to reach out.
I have a question. Where does the name Savick come from?
That's an interesting story, actually. It's a combination of both my and my wife's name, but then found out later that it's also the Inuit word for knife. And so kind of thinking about how maybe you could be on the cutting edge of technology.
That's so cool. That's very cool. Awesome. Great. I really like the roller coasters and the upside down roller coaster images that in your slide deck, and wonder if you've ever felt like you were in the, what's it called? Something, the tunnel, the doom, the bottom of
the Valley of Death.
The Valley of Death, yes.
Yeah. No, I think a lot of entrepreneurs have exposure to that.
Feels like that you've kind of not quite hit that part of it.
I think we're just getting towards the bottom right now, because hiring a few people without a lot of money coming in, definitely have to keep a pretty close eye on things, because it could turn sideways pretty quick if you're not very cognizant that all this work, you could end up declaring bankruptcy just because it took too long, to get a product to market. So time is definitely of the essence right now.
One of the motivations for me joining today was to see this in terms of a household application. So your demonstration is currently a shed. You mentioned about a home application in Edmonton. Did I hear you correctly, Sam? And are you focusing more on agricultural applications, or are you looking at the housing market?
you know, when I started working on this, it was exclusively looking at residential applications. And I was actually really motivated by the issue of energy poverty that we have in Canada. You know, like, I think it's a quarter of Canadians pay more than 10% of their income, you know, towards energy. And so, like, well, if we can build homes that, you know, don't take much energy to consume, then it'd be a pretty compelling product. I didn't really know about passive house or net zero really very much back then. I've since been really, really glad to learn more about it. Yeah, so the original intent was residential, and looking at both, you know, kind of, you know, custom homes, and then also having a few pre-designed plans as well, where we've already done all the computer modeling and everything. So it just really brings the design costs down, and depending on where the project is and its constraints, could reduce the engineering burden as well. So that's kind of, yeah, I'm really interested to see how things go with the residential, even just the permitting side of things, how that goes in the next year.
Thanks. Well, good luck to you, because I'm going to be watching your progress.
Okay, well, you can, yeah, maybe give us a follow on social media or something like that. Because yeah, definitely trying to keep everybody updated, because it's very, very fun to be working on it.
Thank you so much for coming, everybody, today, and keep in touch with Sam.